Very good morning to all the students. I am Dr. Hima Bindu from the Department of Mechanical Engineering from Institute of Aeronautical Engineering, and I'll be dealing the subject robotics. And my today's topic is robot cell design principles. Right. So, firstly, we need to know what we mean by the robot cell design principles. That is, in order to design any particular robot, we should follow some principal rules, right? In order to have a smart manufacturing being integrated towards the real-time understanding or reasoning or planning or management of all aspects of manufacturing or supply chain enterprises, we need to follow some design principles, right? So generally this particular smart manufacturing is used for advanced sensor based data analytics or modeling or and simulation in the real time examples. Which are the real time examples? Now this smart manufacturing system is being available when there is a requirement, when there is a need, where it is a need and it is the most useful infusion manufacturing intelligence throughout the life cycle or the design, engineering, planning, and production. So here SMLC means Smart Manufacturing Leadership Coalition. This is the principle which we need to follow. That is Smart Manufacturing Leadership Coalition. We should come across the smart manufacturing system rather than going for a traditional designing or designing principles. So now whatever are the robots which we are manufacturing, we have to come up with an idea of smart technology or smart manufacturing system. Right. So this particular robot cell description here, it is based on the manufacturing cell, that is the system, or a large unit such as the workshop. Generally, it has been occurred in the system, manufacturing cell system, or in the large scale unit workshops. So here we consider a closed system within which a large unit, it is a robot based manufacturing cell. We consider a closed system within which we have a large unit or the workshop. Now, this particular system can be described with the help of dimensioning its main parts, giving relation between them and the structure of the system. So, this is how we describe the robot cell description. So, here we can see a flow chart that are the stages of robotization which we follow in the design principle of the robot. That is, first we need to analyze. Right, first we need to analyze what to be done and how to be done. That is suitability, what is the required suitability, and then we need to come for the selection of the IR. Right, that is these selection of the IR and robot system design come under the layout. Initially we need to do a layout where we do the selection of the IR and the robot system design, which are being effected with the help of the selection of the components. Right, that is, first we need to draw a layout, and then we need to select the required components, and then we need to start analyzing and we need to start designing, followed by the estimation of alternatives or simulation. Right, we need to estimate the alternatives which are going back, which acts as a payback analysis. Right, which act as a payback analysis. That is, we need to estimate the alternative, and then we need to go for the simulation process. Right, then we need to go for the simulation process, where in the simulation we come across the production cycle. In the simulation process of the robot design, we come across the production cycle, where this also acts as a payback analysis. And then we come across evaluating the final result. After the design is done, we need to evaluate that particular design, whether it is correct or wrong, whether it is appropriate or not. We need to evaluate the final result, followed by the design of the robot based system. Right, now we need to come across the system utilization and continuous improvement. After the robot is being designed, we need to start using that particular robot in a continuous process, and if there are any improvements to be done, that will be a continuous implementation process, coming with the estimated result and the real results, which are being accumulated by the estimated result and the real result. So these are the stages which we will be following in the robotization. That is suitability analysis, selection of the IR, robot system design, estimation of the alternative, simulation, evaluation of the final result, and the design of the robot-based system, and the final conclusion, that is system utilization and the continuous improvement based on the selection of the component, based on the layout which we are drawing, based on the payback analysis, based on the production cycle, and the estimated and the result, final result, that is real result whatever we are getting. So this is how we generally do the robot cell design in the different stages, right? Now, the whole planning system is based on the hierarchical decision making scheme. So, we will be taking a hierarchical decision making scheme for the whole planning system. And the nodes on it represent the decision center. On these centers, the elementary estimations are carried out. These elementary decision making procedures are carried out on the basis of different mathematical methods and the systems of the team. Now, the elementary decisions which could not be in conflict with each other for this purpose, there are coordinate levels where the elementary decision analysis, these are given by the activities, that mean that the modeling and the optimization techniques are integrated with the expert systems. That is, when the system is going across the planning architecture, we should have a correct data storage unit, we should have a correct decision making mechanism, and there should be a knowledge base and integration when any particular manufacturer, any particular robot has to be designed, right? That is, a system should have a good planning architecture, like the robot should have a good data storage, it should be able to do a good decision making, and it should have a knowledge on the base and interpretation. These are very important terms which we need to consider while designing the principle. Now, this robot cell design process is generally being used for the design process, locating location in the workshop and communication, integrate what are the integrated needs, what are the process description, what is the layout alternative, right? What is the selection principle, or what is the alternative estimation which we are coming across, and what are the own designs of the end effector, or the layout presentation, or the commercial or the own design that is needed fixtures. That is also very important. So when we are designing any particular cell, it involves the environment where the robot can operate very effectively and very safely within the manufacturing or the production setting. Here are the key points, that is safety. We need to come across safety. Safety is very important when we are manufacturing any robot, right? That is risk assessment. We need to identify what are the potential hazards, and we need to ensure the safety measures in that particular thing, right? And coming across the physical barriers. Physical barriers may be such as fence, light, curtains, or safety mats to protect the human from the robot operating area. When the robot is operating any particular, we need to we need to consider the safety barriers, we need to consider the safety mats, or we need to protect from the robot operating area, or the emergency stop. We need to include the easy accessible emergency stop button to halt the robot operation in case of any emergency. If the robot is acting beyond its particular perspective limit, we need to have something, we need to have an emergency stop button where automatically the robot will stop acting on the unwanted areas, like, and safety interlocks. That is, we need to initiate the integrated interlock system that disables the robot when access doors are open, right? So these are very important when we are planning the robot cell. And next, coming to the efficiency and flexibility. In what form the efficiency can be increased? By arranging the robot workpieces, equipments, or optimizing the workflow, reducing unnecessary movement of the cycle time, or designing the tool and fixtures for the work pieces, or for material handling systems such as conveyor or automatic system. We should increase the efficiency of the usage of the robot. And these are also very important. But when we are considering the flexibility, we need to take care that the components that can be easily reconfigured or upgraded should be have a good production changes, or the reprogramming and adaptation to handle different tasks for the product have to be significant downtime. right? And the cost effective budget constraints, we need to take care of the budget constraints. We should have a balanced budget for the designing between the performance and the cost, ensuring that the robot cell provides a good return or the investment. Whatever we are investing, we should get back that particular return or investment. In that way, we have to plan our particular budget. Or the energy efficiency, we need to take care that we need to reduce the optimization cost for the energy, that is incorporate energy efficiency components and design that particular robot which can reduce the operational cost. And coming to the standard regulation, we should follow the ISO, ANSI or OSHA guidelines. In order to design any particular robot, we need to follow ISO principle, ISO regulation, or ANSI or OSHA type of the guidelines in order to get a good designed principle, that is designing a robot cell that is safety and which is very efficient and flexible and well suited to the specific needs of the production process is very important, right? So these are the differences which you have gone through for this particular topic. So in the today's class, we have discussed about what are the various efficiencies required, what are the various flexibilities, how can we come across the budget efficiency, or how can we come across the energy efficiency standard, what are the various standards and the regulations which we need to follow to design any particular robot, right? And what are the various safety precautions which we need to take while designing the robot, and what are the designing process we have seen, and what are the various stages which we have gone through this particular flow chart of robotization. And we have come across the generalized what do we mean by smart manufacturing and why this should be included in that designing principles, right? Hope you have understood today's class. Signing off for today, Dr. G. Hima Bindu. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.